In this video, I'm not really introducing arrays, as many of you have already seen arrays in whatever beginning course or lecture series you watched or took a part of. It's more of a recap of arrays, but if you've never seen what arrays are before this video, it should be enough to get you started so we can move forward in the data structures and algorithms videos. Using the terminology that we learned in the previous videos, an array is a static and linear data structure that stores homogeneous data. So basically that means that an array is stored sequentially in memory and that the size of this array is determined at compile time. Now with all this together and knowing that the data that we store is homogeneous, it's all one data type, we get the property that arrays are randomly accessible, meaning I don't have to start at the beginning of the data and work my way through to find what I want. I can just hop to the location that the data is. So if I want to go to the 7th element of the array, I can just go directly there. And that's why we consider arrays to be randomly accessible. Now, in terms of the behaviors of an array, well, quite frankly, there are no predefined behaviors of the array. There is no ordering to how we can manipulate the data or how we store the data. An array is just a simplistic structure that tells us the data has to be of like type and that it's sequentially stored in memory, and that's it. Now, arrays don't even have additional information, so we don't even know the size of the array. Other than when we define it at compile time, there is no variable, there is no way of knowing what the size of the array is. Now in C++ and other languages, there are ways that you can do some pointer arithmetic and determine what the size of the array is, but that's not really a good approach because once you leave the scope that the array was declared in, that arithmetic breaks down and it's not a really good way of going about things. So in practice, arrays are just a simple data structure that have no definitions of how you manipulate and store the data. You can kind of put the data in any way you want as long as they have the same type and they're sequentially stored. And we don't know the size of the array other than at compile time we know that we're fixing the size of the array. Even though arrays are relatively simplistic when it comes to a data structure, there's a lot of advantages that they give us. And the first is that we can store a large amount of data under a single structure. Also, arrays are very easily searched and sorted. We can just kind of iterate through the array, and because we know everything is stored sequentially, it's easy to get to the data that we need, and it's easy to move that data around within the structure itself. And because of this, we find that arrays are common building blocks that we see within other data structures. Now, one that we're going to see later in this lecture series are trees. And arrays are a common way that we store the data that belongs to a tree. And the reason why we see this is mainly due to the property that data in arrays are randomly accessible. So that's one of the key things, is that we can just kind of hop around the array as needed and grab the data and move the data. And that's why we see that it's a pretty common building block. Even though that arrays are a very simplistic, static, linear, homogeneous data structure, we're going to see, moving through this lecture series, that they turn out to be a very versatile and useful data structure.